C++ provides several predefined macros created with the #define directive that will give us more information about where in the file we are and also what day and time the file was compiled. All of these predefined macros have names that begin and end with double underscore. So for example, __ file in all caps __ will be the name of the source code file containing this particular code. __ line in all caps __ is the particular line number in the file. Here on slide 13, we've expanded our code example. Let's suppose that this is in a code file named ex1.cpp, so that when this out of range error is generated by calling the @member function with a bad subscript, the out of range exception is caught in this catch block, and we can display in file and the file name ex1.cpp @line, whatever this line number is in the file, in function, whatever function we're currently in, compiled on this particular date at this particular time, we have what happened. Now notice this reports when the program was compiled, not when this code was executed and this exception was thrown. Also, another problem here is that I'm being told where the exception was caught, not where the exception was thrown. So it's better than nothing, but still not quite what we're after. Here's the output that I would see. In file ex1.cpp @line 128, assuming this was line 128, in the function abc, blah, blah, blah. Okay, so we've taken a look now at situations that generate exceptions, such as trying to allocate too much memory or using the @member function with a bad subscript. And we've seen how to catch these exceptions. We haven't talked yet about how you can throw exceptions yourself. You can throw an exception by using the throw keyword followed by an exception object. Now, that exception object can be of any data type at all, even something really simple like an int. When you throw this exception, your program will do what's called unwinding the stack, searching upward and upward in the function call hierarchy until a matching catch block is found that's waiting for your type of exception. And if there's no catch block that's waiting for your type of exception higher up in the function call hierarchy, then the program will crash. Okay, so here on slide 16, we have some code illustrating a couple of different kinds of throws. We've got v as our vector of int containing 4 elements. I'm going to randomly choose an index between 0 and 7. And if the index is bogus, that is, if it's greater than or equal to the size of the vector, then if the index is an odd number, that is, if index mod 2 is 1, I'm going to throw a string. Okay, that is, I'm going to throw a pointer to a char. Otherwise, I'm going to throw an int, specifically the index. Now, on the other hand, if idx was less than v.size, I'll drop down here to this cout statement and say v sub, whatever the index is whatever the value at that index is. So, for example, v sub 0 is 2, or v sub 1 is 4, or what have you. In the remaining part of this code on slide 17, I have a couple of catch blocks set up below the try block, the first of which will catch a thrown string, that is, a thrown pointer to char, and simply display whatever that message is. The second of which will catch a reference to an int and print out a message saying bad subscript and whatever the int is. Here on slide 18, I have a few test executions of this little program containing this try block with these 2 throws and these 2 catches. The $ symbol here is the Linux prompt, or the Unix prompt, or the Cygwin prompt. You can install Cygwin on Windows. Cygwin provides a Linux-like command line environment with a bash shell and the whole collection of Unix/Linux commands. To execute an application in Cygwin or Linux, you specify the directory where that program is contained. Dot means the current directory, and slash is the directory separator. So ./ex2 is how, on a Linux or Cygwin system, I would execute the ex2 executable program file that's in my current directory. Okay, so I do this once, and I don't have an error. I get told that v sub 3 is 8. I execute it again, and I get apparently a bogus even-numbered subscript generated. That throws an int, as you may recall. Let's take a look back on slide 16. All right, so if I get a bogus even-numbered index, that throws the int. The int is caught here on slide 17, and I display the message bad subscript and whatever the value is. So I get told bad subscript 6. The third time I run ex2, I get a good subscript. I get a 2 as my subscript, and I get told that v sub 2 is a 6. And then the fourth time, I apparently get a bad odd-numbered subscript. And so we throw this message, bogus odd IDX. That gets caught by this catch block, and it's simply displayed. Okay? Okay, so the bottom line here is that an exception is an object of some type. And you can throw any object of any type, and that either will match up with a catch block higher up in the function call hierarchy, or it won't, in which case your program will crash. Now, because an exception is simply an object of some type, it's very easy to define your own exception class or classes if you wish. In fact, an exception class does not even have to have any members within it. Here we have an exception class. The name of this class is bad thing. It has no members. The compiler will automatically give you a default constructor for this thing that does nothing. And over here on slide 20, we have an illustration of how we might use this bad thing exception class. We've defined the class in our code above the place where we want to use the class. And here in this try block, we're once again selecting a random index between 0 and 7. So half the time our index is going to be outside the bounds of this vector. And if we discover that the index is bogus, we can say throw a bad thing. Now, bad thing is a data type, but bad thing with 2 parentheses after it, that is how you invoke the default constructor to build a bad thing object. What's maybe a little weird about this is that this bad thing object doesn't actually occupy any space. But it is nevertheless a bad thing object, and consequently you can have a catch block set up looking for a bad thing. In this case, since the bad thing does not contain any information at all, you don't even need to specify a parameter name. But when a bad thing is thrown, this catch will catch it, and we can display to the screen that we caught a bad thing. Here on slide 21 are some example executions of this little program in a file called ex3.cpp. Again, we're executing this in a command line oriented Linux environment. By the way, if you did this in a Windows environment, the only difference would be that you would have like a C and a greater than symbol here to indicate your prompt. And you probably wouldn't need to type the directory name. You could just say ex3.exe to execute that program, and the behavior other than that would be the same. Alright, so here we're executing ex3, and apparently this first time we're getting an index of 3, which is within range, so we get told that the value of ex sub 3 is 8. We execute ex3 again. This time we get a bogus index, and we throw a bad thing object. We catch it, and we display that we caught a bad thing. We run it again, and we get a valid index. We run it a fourth time, and we get another bogus index and display that we caught a bad thing. Okay, so for simple cases where you simply want to know, did something go wrong or not, you can trivially create an exception class containing no members, and then you can construct and throw one by giving the class name in the parentheses. And in your catch block, you can set up to receive a reference to this bad thing, even though the bad thing doesn't contain any data.